Amazing, right? And we see it in our world. We see it in our world, the strength of good, solid engineering. Taking the time to plan out how this building is built. Taking the time to find the right materials. Learning how to build the things we want to build, right? Does that make sense? Eli, what's your question?
The space needle was a lot of work because it's really thin, so it's really easily to
That's right. The Space Needle is really thin, but it took a lot of engineering. Because if you look at the Space Needle, you know what? I might even draw up how the Space Needle was built. How does that sound?
No.
I think we're going to do that because we're going to talk a little bit about a couple of other things. I've got some snacks that we're going to have while we talk about these things because there ain't too many people here. They're going to get to enjoy some marshmallows since y'all ain't here. Here we go. All right.
Yeah!
So, these marshmallows, first off, don't eat them yet.
Oh man.
First, we got to do a little demonstration with them. Marshmallow. 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 Oh, you've got to hold that thing more still. You can eat this later. All right. Okay. Everyone take a marshmallow, hold it up. Now, take your hands. Put the marshmallow in the flat of your hand like this. Take your other hand and go like this. And then start to push. What's it doing?
I killed it.
You call this compression. What we're doing is we are compressing the marshmallow, right? Now, I want you guys to see something else. Take 2 fingers from one hand, go to one side of the marshmallow, and squeeze only one side of the marshmallow.
Oh my goodness.
Do you notice how one side of marshmallow is going smaller and the other side of marshmallow is spreading out? The other side is doing what is called tension, whereas this side of marshmallow is going what's called compression. Compression is when we force something together. Tension is when we stretch something out, right? Enjoy your marshmallow.
Daddy, this is hard as well. I can't squish it too hard.
So that is an example of compression. Now, we got more snacks here. I'm going to grab some Twizzlers. Another thing that we got to talk about, since we're talking about compression, we're going to talk a little bit more about tension, which we said is on the other side of that marshmallow, right? I'm going to draw an example of that. In fact, the Space Needle is an amazing example of that. So these Twizzlers, here we go. Twizzler, 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 Twizzler. Right. So Twizzler, you look at Twizzler. Okay. So far I've got it straight, right? Now imagine twisting it.
I twist it.
Twist it, right? We call that torsion. Torsion is just a measure of something twisting, right?
Then,
There are things.
and then it bends.
There are things that twist for other reasons or not. Okay. Now take your Twizzler, hold it on both sides, and pull out
I killed it.
slowly. So this puts this Twizzler under what is called tension. So it's being pulled, which is tension. If you pull slowly, you'll notice it stretches slowly, right? So,
I think the Twizzler is too weak.
the tension, we use different building materials. Some building materials are great for holding up against compression. Others are good for holding up against tension. A great example of this is if you look at a bridge. For instance, if you have a drawbridge, have you guys ever, or a tension bridge, have you guys ever seen a suspension bridge like the Tacoma Narrows? Is it Tacoma Narrows a suspension bridge? I don't remember now. Here's an idea of a suspension bridge, right? You have 2 towers. Tower 1, whoop, whoop. tower 2, whoop, whoop.
I can go out.
And between the two towers is a big wire. That wire is being pulled between these two towers. That means it's under what? What?
Tension.
Tension, right? It's under tension. In fact, it's got more than just tension there, right? It's got tension from a bunch of other wires that are hanging down
And then it's
off of
going
there.
out.
The reason why all of those are under tension and pulling on this one right here is because underneath this, you have a bridge attached to it.
That's not a bridge.
It's a bridge. It's not as round as it looks, but it's a nice curve, okay? So that bridge is being pulled by the ropes right here, right? So as the wires are being pulled that way, all those ropes are under tension. Now the reason why so many hang from up here is because we want to distribute evenly how much weight is felt, or where the weight is felt by that top wire. Let me show you guys an example. Alyssa, I want you to hold this just like this, okay? You gotta hold it up flat. Now, I'm gonna push down in the middle. Where do you feel it?
Both sides.
Both sides, okay? Now watch what happens if I push down over here. Where do you feel it?
This side.
Just that side, right? So, by spreading out the weight, it makes it so it's felt. Is it easier to hold up with 2 fingers or just 1?
Different.
Right here. I want to show you the same thing. Ready? 2 fingers out. Okay, here you go. Ready? So if I push down in the middle, you feel on 2 fingers, right? If I push down over here, it's just 1, right? So it's better if we can make it be felt. Spread them out a little bit. Go to the edges. There you go. See both? Or just 1? Okay. It is better if you spread it out across the entire thing. And some materials, like I said, are better at tension. Some materials are better for compression. And some materials are good at both. Do you guys remember how we talked about the marshmallow? We had one side going into tension, one side going into compression. So if you picture this bridge right here, and instead of it being curved this way, let's say it was flat. And while it's flat, we're going to say there's these lines. We're going to call these tension compression lines. Just drawn straight across, evenly spaced. Okay? Here's what it would look like if we move those lines up to here. Because of the way it is, it would cause... Okay, so I'm not good at this. If we had a sponge, it would, you know what? Watch this.
There are sponges.
You know what? You have a sponge?
Yeah.
Where? No, we're not going to use their sponges because I'm not going to draw on their sponges. What I'm going to do, watch this. I'm going to draw on this marshmallow. Look at it. This is an idea just on the fly. Draw on this marshmallow. We probably shouldn't eat this marshmallow after this. Maybe I'll send it home to y'all.
Chocolate flavored.
Okay, so now draw another line. So the idea here is we're going to keep these lines as close together as we can. I mean, evenly spaced. I hope this works. 'Cause I didn't practice this. Now, all the lines are pretty evenly spaced, right? Now, what happens in that bridge example, right? You have one side under compression, one side under suspension. What you would get is one side, the top part is spread out, and the top part, the bottom part is closer together, right? You got materials that are good at both compression and tension at the same time on different sides because of the way the material is being used. So like Alyssa mentioned the Space Needle.
Oh, Eli.
Eli mentioned the Space Needle. The Space Needle, which has this flying saucer thing looking thing at the top.
can draw it for you.
Right? And I am not an artist.
I'll draw it.
It's okay.
It's just a straight line.
Right? And then there's this piece in the middle that holds kind of the weight kind of sits on. But then to give more strength, if you notice, there are these bars that come off the space needle like this.
I noticed that.
See that? Right
Oh,
here.
yeah.
It looks like a mushroom held up my fingers.
That gives it strength because these pieces here are under tension on the outside and compression
On the inside.
on the inside of the curves. And that design right there is what gives that space and strength to stand as tall as it does in all the winds and storms that blow through Seattle. Is that cool?
Yeah.
Pretty neat, huh? Let's see here. How are we doing on time?
Good.
I think the next thing we're going to do, because we're going to turn this off here for a second, is we are going to be building a couple of different structures to test the strength of. We're going to build a cube. If you want to do this at home, you simply use toothpicks and gumdrops. Toothpicks and gumdrops. One is just simply a cube. The other, we're using triangles to form the same square shape at the top or to hold weights. I'll turn the video back on here in a minute so we can put books on and see which of these structures are stronger.